Good day to everyone. We hope you're all safe and healthy. Kung medyo mahina yung volume, pwedeng pakilakas ng konti. Today's lecture will be about graphs of functions. If you want to take down notes, you can pause this video and continue playing if you have already taken down notes. Okay. So this is the outline for today's lecture. First, we discuss the graph of an equation. Then we discuss polynomial functions. Then rational functions. Then we go to piecewise defined functions. We proceed with the graph of an equation. Recall that given an equation in x and y, the graph of this equation in R2 is the set of all points xy in R2 such that x and y satisfy the equation. Example, sketch the graph of the equation y equals x plus 2. Recall that this equation, its graph is a line. So we get some points on this line. If x equals 0, then y equals 2. So the point 0, 2 is on the graph. If y equals 0, then x equals negative 2. So the point negative 2, 0 is on the graph. We now sketch the graph on the xy plane. We plot the points 0, 2 and negative 2, 0. Connect these 2 points to form the line. Okay. Next, sketch the graph of the equation x squared plus y squared equals 4. Recall that the graph of this equation is a circle. The center of this circle is at the point 0, 0. The radius of this circle, since 4 equals 2 squared, the radius equals 2. Let's get some points on the graph. If x equals 0, then y squared equals 4. So y equals plus or minus 2. So the points 0, 2 and 0, negative 2 are on the graph. Now if y equals 0, then x squared is equal to 4. So that x is plus or minus 2. So the points 2, 0 and negative 2, 0 are also on the graph. We now sketch the graph on the xy plane. We plot the points 0, 2, 0, negative 2, 2, 0, and negative 2, 0. We connect these points to form the circle. Okay. From the graph of an equation, we can tell if y is a function of x. We use the vertical line test. Every vertical line intersects the graph of a function in at most one point. If the graph of an equation defines that y is a function of x, then the domain of this function is the set of all x coordinates of the points on the graph, and the range of this function is the set of all y coordinates of the points on the graph. Okay. We determine whether the graph of the equation y equals x plus 2 defines y as a function of x. We already have graphed this earlier. Okay. If we think of any vertical line and let it pass through the graph, then it will intersect in exactly one point on the graph. So every vertical line intersects the graph exactly once. So y is a function of x by the vertical line test. Okay. Now we consider the domain of this function. The domain of this function is a set of real numbers. Since every real number represents an x-coordinate in the graph, the range is also the set of real numbers. Since every real number will have a corresponding y-coordinate on the graph. Next, we consider the equation x squared plus y squared equals 4, which we have graphed as follows. If we look at the y-axis, which is a vertical line, it will intersect the graph in 2 points, 0, 2 and 0, negative 2. So there is a vertical line that intersects the graph more than once. So y is not a function of x. Okay. Next, we proceed to polynomial functions. Recall that a polynomial function is a function of the form f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus and so on plus a sub 1 x plus a sub 0, where n is a non-negative integer, a sub I is a real number for each I from 0 to n, and a sub n is not equal to 0. The degree of the polynomial f is n. Okay. Examples of polynomial functions are the following: f of x equals x plus 2, g of x equals x squared, and h of x equals 5x cubed plus 6x squared plus 1. The domain of a polynomial function is the set of real numbers. Okay. We have some examples of polynomial functions. A constant function is a function of the form f of x equals c, where c is a real number. The domain of this function is the set of real numbers. The range of this function, since there is only one possible value for f of x, which is equal to c, the range of f is equal to the set containing c. The graph of this function is a horizontal line passing through the point 0, c. So this is a sample of a graph of a constant function. Okay. We proceed with a linear function. This is a function of the form f of x equals mx plus b, where m and b are real numbers and m is not equal to 0. The domain of a linear function is the set of real numbers. The range is also the set of real numbers. The graph is a line with slope m and y-intercept b. We will look at the y-intercept later on. If the slope is positive, then the line goes up as we move from left to right. If the slope m is negative, then the line goes down as we move from left to right. Okay. To graph a linear function, we need the x and the y intercepts of that graph. Let f be a function and let y be equal to f of x. Then the x-intercepts of the graph of f are the values of x for which y or f of x equals 0. If 0 is in the domain of f, the y-intercept of the graph of f is f of 0 or the value of y when x equals 0. Example, we sketch the graph of the function f of x equals negative 2x plus 5. The graph of f is a line since the function is of the form mx plus b, where m is negative 2, b equals 5. The slope is negative 2. We now find the intercepts. If y equals negative 2x plus 5 equals 0, solving this equation gives us negative 2x equals negative 5, so that x equals 5 over 2. So the x-intercept is 5 halves. This means that 5 halves 0 is a point on the graph. Now, if x equals 0, then y equals f of 0 equals 5. So the y-intercept, this is equal to 5. So that 0, 5 is a point on the graph. From here, we are now ready to sketch the graph of the function. Let's say this is the xy plane. We just plot the points 5 halves 0 and 0, 5. And then we connect these 2 points to form the line. This is now the sketch of the graph of f. Okay. We now proceed with quadratic functions, which are functions of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. The domain of a quadratic function is the set of real numbers. The graph of a quadratic function is a parabola. This parabola opens upward if a is greater than 0 and downward if a is less than 0. A parabola has a vertex, which will have coordinates negative b over 2a, 4ac minus b squared over 4a. Or we think that the x-coordinate of the vertex is negative b over 2a, while the y-coordinate is just the function value of negative b over 2a. The vertex is the minimum point or the lowest point of the parabola if a is greater than 0, and the maximum point or the highest point of the parabola if a is less than 0. A parabola will be symmetric to this line of symmetry with the equation x equals negative b over 2a, the vertical line passing through the vertex. If a is greater than 0, then the parabola will look like this. It opens upward. The vertex is a minimum point, and this is the line of symmetry. Notice that the points to the right of the line of symmetry will just be the mirror image of the points on the left. Now, if a is less than 0, the parabola looks like this. It opens downward. The vertex is the maximum. And this is the line of symmetry. Okay. For example, we sketch the graph of the function f of x equals x squared minus 2x minus 3. The function is of the form ax squared plus bx plus c, where a is 1, b is negative 2, and c is negative 3. The graph of this function is a parabola. It opens upward because a equals 1 and it is positive. To find the vertex, we use the formula. And then we plug in from the values of a, b, and c. And we get the coordinates 1, negative 4. Okay. We can also compute for the y-coordinate of the vertex by computing for the function value of negative b over 2a. The vertex is a minimum point since a equals 1 is greater than 0. And the line of symmetry is the line x equals negative b over 2a or x equals 1. We now proceed with the intercepts. If y equals x squared minus 2x minus 3 equals 0, we factor out x squared minus 2x minus 3 to get x minus 3 times x plus 1 equals 0. Solving for x, we get x equals 3 or x equals negative 1. So the x-intercepts are 3 and negative 1. This means that the points 3, 0 and negative 1, 0 are on the graph. Now, if x equals 0, then f of 0 equals negative 3. So the y-intercept is negative 3. So that the point 0, negative 3 is on the graph. With this, we are now ready to sketch the graph of the function. This is the xy plane. We graph the point 1, negative 4, which is the vertex. We graph the points 3, 0 and negative 1, 0. These are the x-intercepts. And then the point 0, negative 3, which is the y-intercept. We just connect these points to form the parabola. Note that the parabola opens upward and the vertex is a minimum point. Okay? The domain of f is the set of real numbers, and since the y-coordinates covered by the graph of this function will be from negative 4 upward, the range of f is the interval negative 4 to infinity. Okay. We now proceed to rational functions. A rational function is a function of the form f of x equals p of x over q of x, where p and q are polynomial functions and q is not the constant zero function. The domain of the rational function f is the set of real numbers such that q of x is not equal to 0. So all the real numbers whose denominator q of x is not equal to 0. So all the real numbers such that the denominator q of x is not equal to 0. Example, consider the function f of x equals x cubed minus 2x squared minus 3x over x. This is a polynomial over a polynomial. Note that the domain of f is just the set of all real numbers where the denominator is non-zero. So this is R, not including 0. If x is not equal to 0, then we can divide the numerator by the denominator and get x squared minus 2x plus 3. Meanwhile, if x equals 0, then the value of x squared minus 2x minus 3 equals negative 3. Therefore, the graph of f is the same as the graph of another function g of x equals x squared minus 2x minus 3, but the point 0, negative 3 is removed since 0 is not part of the domain of f. And negative 3 is the value of x squared minus 2x minus 3 when x equals 0. This is the graph of g of x equals x squared minus 2x minus 3. This is a parabola. We have sketched it already earlier. Now, this is the graph of f. It's a parabola, but we remove the point 0, negative 3. That's why we have a hole in this part. The domain of f is R, not including 0, and the range is the interval negative 4 to infinity. Because although the point 0, negative 3 is removed, if you look at the points from the vertex to the right of the vertex, we can say that there is another point here whose y-coordinate is negative 3. Tuloy-tuloy lang kasi umaakyat yung graph dito. Okay? So the range is still negative 4, infinity, the interval. Another example, sketch the graph of the function f equals x squared minus 4 over x plus 2. The domain of f is the set of all real numbers whose denominator is non-zero. So R, not including negative 2. If x is not equal to negative 2, then f of x is equal to x plus 2 times x minus 2 over x plus 2. So we have factored the numerator. We can cancel out x plus 2, so we get x minus 2. Meanwhile, if x equals negative 2, then the value of x minus 2 is negative 4. Therefore, the graph of f is the same as the graph of g of x equals x minus 2, but with the point negative 2, negative 4 removed. Negative 2 is not in the domain, and negative 4 is the value of x minus 2 when x is negative 2. The graph of x minus 2 is a line, so we get the intercepts. The x-intercept of this line is 2. so that the point 2, 0 is on the graph of f. Also 2 is in the domain of f. The y-intercept is equal to negative 2. Note that 0 is an element of the domain of f. So the point 0, negative 2 is on the graph of f. Okay. We are now ready to sketch the graph of this function. This is the xy plane. We plot the points 2, 0, 0, negative 2, and we have a hole on the negative 2, negative 4. Because negative 2 is not part of the domain. We just connect these to form the line. But we remove the point negative 2, negative 4. The domain is the set R not including negative 2. And the range is the set R not including negative 4. Because if we look at all the other points, we cannot have any point with y coordinate equal to negative 4.